Okay, so here we learn how to find the domain of a function. And this is one of the topics discussed in section 2.6. Okay. The point of finding domain, we've learned quite a few different ways how to find domain of a function. But one of the way I introduced so far in class is the way how to determine the domain of a function by looking at a graph. Now the point of these examples here, the point of these exercises here is to be able to find the domain of a function without looking at the graph. So let's look at the first function here. Example number 1. And we want to find the domain. And the first function that we're looking for the domain is 3x minus 1. So here I have a function f of x equals 3x minus 1. So in class I already discussed that whenever you're getting into these finding domain problems, there are mainly two concerns. One concern is about the denominator. Let me repeat one more time. The denominator, the quantity in the denominator cannot be equal to 0. And then the second concern here is that the quantity underneath any square root cannot be a negative number. And so in this problem, in this function right here, out of the two concerns, none of those we have to be worried about. So in this function, we have no denominator, we have no fraction, we have no square root. So none of the concerns is addressed here. So in that case, this function here, since we're free of all the concerns, the domain would be, the domain for this problem would be all real values of x. Okay, but then all real values of x, a lot of time the domain is required to be written in interval notation. So all real values of x, that logical meaning can be re-expressed as an interval notation, meaning negative infinity to positive infinity in parentheses. And that's how we find the domain of this function 3x minus 1. And so once again, let me recap one more time before we move away from this example. Right from the beginning, this function 3x minus 1 has no fraction, so we are free of the concern about the denominator. And on the other hand, this function has no square root, so the second concern is also free from us. So we don't have to worry about the square root. So that means this function here should be able to take any value of x, or in other words, the domain of the function is all real values of x. And in interval notation, this is how we write the domain, negative infinity to infinity in parentheses. Okay, so in example 2, let's look at another function. We want to find the domain. And the function that we have here is f of x equals x squared minus 4x minus 5. So surely the function this time in example number 2 looks different from the first example. However, once again, let's check with the two main concerns that we have. Is this function having fractions? And the answer is no. On the other hand, is this function having square root? And also the answer is no. So meaning, once again, this function is free from the two main concerns that we have. That also means that this function can take any value of x for input. Or in other words, you can say that the domain is all real values of x. And then expressing the domain in interval notations, it's from a negative infinity to positive infinity. And that's how we find the domain for this function, x squared minus 4x minus 5. In example number 3, let's look at a different function this time. Find the domain. And the function that we have here is f of x equals 1 over x minus 5. So now at this point, you can start realizing that as I verbalize the function itself, now we're seeing that this function has a fraction nature where my numerator of the whole function is 1 and my denominator is x minus 5. So now, out of the two concerns, this function runs into the first concern. Concern number 1 is about the denominator, which is the entire quantity x minus 5 right here. The denominator cannot be equal to 0. And so, that means we're going to have to find the domain. We first need to spot out or find all the bad values, all the values that make the denominator equal 0. And by doing that, I'm going to set the denominator equals 0. And then I'm going to solve for x. So solving for x in this problem, I'm going to add 5 to both sides of the equations. And here I have x equals 5. But here's, keep in mind, be careful. X equals 5 is the bad value, the value that caused the denominator of this function to be equal to 0. So the domain is going to be any x value except 5. Any x values, any other x value other than 5. So that's how we find the domain. And now writing this domain here in interval notations. The easiest way to help you visualize the domain is to draw for yourself the line of numbers. And here you can think about 5 is going to be anywhere on the line, and say the way how the logic here is that for the domain of this function, the function takes any x value except 5. Meaning on this line of numbers, you're going to go ahead and shade everywhere else besides 5, so that you can see right at 5 I'm putting a circle there. And so looking at the visual display of this domain right here, and that can easily give you the domain in interval notations. So here I have minus infinity to 5, that's one interval. And then I also have 5 to positive infinity. That's what the shading here is indicating. And now I'm going to join the two intervals here by a union sign. And that's how I write. This is my final answer to the domain in interval notation. So, in another example, in another example, you can see that, let's look at a different function. F of x equals x over x squared minus 5x plus 4. And once again, we would like to find the domain of the function. Alright, so now once again, as I finish writing out this function, if you look at the overall expression of the function here, once again, what caught my attention here is this function is having a fraction nature. So there's the numerator, which is the x. The denominator of that fraction is the entire quantity, x squared minus 5x plus 4. And then you can also check again throughout the entire expression here, there's nowhere you're seeing a square root. So meanings out of the two concerns, out of the two main concerns, here in this problem, we're running into the first concern where we're having a denominator. And so I need the denominator. As the rule, the denominator cannot be equal to 0. So meanings I'm going to have to go ahead and set my denominator. X squared minus 5x plus 4 equals 0. What I'm doing here is I'm going to I'm trying to find all the values of x that makes the denominator equal 0. And I'm going to exclude all those bad x values. So here, to find all the x values that bad for the functions, I'm going to have to solve this equation. And the way to solve, factoring is the easiest way for me so far. And so here I produce for myself two pairs of parentheses again. And here I have minus 1 and minus 4. Okay. And so, solving further, I have x equals 1 and x equals 4. So, and once again, keep in mind one more time, these two values that you have obtained after solving the equation, they are not your domain. They are the bad values that you should exclude from the domain. So, the domain in this problem is going to be any x value except 1 and 4. Except 1 and except 4. So that's the logic. Because once again, these two values, x equals 1, x equals 4, makes the denominator of this function equals 0. And those are the bad values. So the domain is going to be any other values besides 1 and 4. So now, to write the domain here in interval notation. What helps you here is to create for yourself a line of number, and you're going to put 4 and 1 here in increasing order from the left to the right. And once again, the logic here says I want any other x value except 4 and 1. So that means I'm going to shade anywhere else besides 4 and 1 on my line. I'm shading anywhere except 4 and 1. And so here, right on 1 and right on 4, I'm putting circles around them, indicating that we're excluding those two specific values. And so now, the graph here is making it clear for you to write your domain in interval notation. So what I have here is, you have an interval. The first shading here is indicating we have an interval from -infinity to 1 in parentheses. And the next shading area is going to be the interval between 1 and 4 in parentheses. And the last shading is the interval between 4 and positive infinity. And now I have 3 little intervals. I am joining them by the union sign. And that's how and that is the answer of our domain problem. This is the domain for the function f of x equals x over quantity x squared minus 5x plus 4, written as an interval.